data-driven product development. So I will start with a short introduction about myself. As already mentioned, my name is Flo. I'm working as a staff engineer at Spotify, dealing with authentication, authorization, and user lifecycle.
Florian, I'll just jump in. If you just could share your slides as well. Sorry, just to jump in there. Perfect, thank you.
I'm sorry.
No problem.
That should be solved now. So, where was I? Yes, exactly. I'm working as a staff engineer, working with authentication, authorization, and user lifecycle. Before we jump into data-driven approaches, I want to outline some key concepts, though, that I personally think are super important to get right. The first thing is why even data-driven? So, did you ever find yourself in a planning session where you've planned certain features or certain systems that are more than, like, let's say 3 months ahead? And then ask yourself, how did that go? I've been in planning sessions where I've personally planned systems or had to size even stories and create stories that were more than 12 months ahead. And it went horribly. Like once we've reached that state, like 12 months ahead, our product looked completely different from what we envisioned it to look like back then. So therefore the question, if you've encountered this situation, did you end up building what your customers really wanted? Or did you end up building what you in the beginning thought would be useful? And if you still think that you've built what your customers really wanted, how did you measure this? Because in my experience, it's incredibly hard to measure the customer success, and it's really, there's no one size fits it all. It really needs to be from system to system, and needs to be defined and probably as well adjusted on the way as you continue in development. So let's follow up with a short story. I'm for myself, I'm usually working remotely with a team in Stockholm, but I'm flying once a month to Stockholm to see my teammates, meet them in person, have some one-on-one meetings, build up relationships, build my network within the company. And there I'm usually flying from Berlin to Stockholm without thinking a lot. I mostly watch Netflix on the planes. So one day I asked myself, though, why are the windows round in an airplane? And I did a bit of research, and it turns out that in the 1950s, there were Comet 1 airplanes, which were some of the first passenger jets. And they quite frequently fell apart while being in the air. No one really realized what was the issue. And thus they started banning these airplanes and say, okay, we just cannot let them fly because they usually have like disasters when they fly. So they banned the airplane, and after 2 weeks of investigations, they couldn't find any reason why it was happening. So they said, okay, maybe we should let them fly again. So they let them fly again, and directly after that, the first plane fell apart again directly after the start. So after a while, like, of course, that then led to a permanent banning of them flying. But after a while, they found out that the problems were in the rectangular windows. And there were small cracks going from the corners all across the body of the airplane. And once the pressure increased, it fell apart. But the way more important finding or the way more important development after they've analyzed that was that they introduced a black box. For all of you who don't know what a black box is, it is a small component that is really hard to destroy, which basically gathers data while the airplane is in the air, while the airplane is operating. And now they can use this data and constantly analyze what is going on while flying, even analyze that data offline and do constant improvements to the airplanes. And I think without that, if we would have just started planning an airplane, like from the beginning, say like, okay, we want to be in the air, and these are the exact steps that we need to follow. And then without testing, just do it, execute on it. I think we never would have ended where we are today. We would have probably never been as fast. And I would even say a more bold statement, and I would even say we would probably still not be in the air if we would not have experimented. So the next part, I want to talk about the importance of a vision. We've already heard it quite some times today about a vision, about like you need to have a vision. But I want to be a bit more concrete here and say, what is a vision? So in my point of view, a vision, in order to formulate a vision, you should ask yourself, what do I see this system doing, or like this feature doing, this product doing, whatever you're at the moment designing, doing in the future, let's say in 2, 3, 4 years from now. It is not about an exact feature definition, like it can be fluffy, or it should even be fluffy. As if you're trying to be too precise, you're gonna fail most likely. We're gonna see why in a second. But then once you formulate that vision, you usually do that in a group of people who are building a system together or a feature together. You're gonna share it with everyone who has a need to know, and you got already the first round of feedback, and you adjust your vision. So why should we even do this if it's not too precise and it's fluffy? The reason is it is great for aligning teams. For example, if there would have just been a vision for the jet, for the passenger jet of, yeah, we should fly. Some people would have maybe envisioned an airplane that does not transport passengers, but rather goods. And others would have maybe envisioned an airplane with, I don't know, 6 wings. So aligning these thoughts makes super much sense. Another example that is from our day-to-day, or like from my day-to-day development, is where we had an account activity service. So we basically thought, okay, what could this system do? And on that, I will go later on in more detail, because this is exactly one of the examples I'm gonna later on discuss in more detail. So, so when you're developing with a vision, this is where you start. You are somewhere today and you envision a future. What will actually happen is that you will most certainly never end up exactly here. You will start iterating on your problems. You will start working, and you will notice that you either pretty quickly derail from your vision and you will actually end up somewhere here, or you will stick quite a long time, and then you will derail from your vision, and you will end up somewhere here. But most certainly you will not end up for the vision. And I think this is not the real task of the vision. A vision is to really align teams up front in what you are envision a system to do, and therefore set a rough timeline of what should be done. Okay, now let's talk about the importance of data in this. I already mentioned it. You're going to iterate, you're going to measure. Very often when I talk to friends in the industry or like to other people in the industry, I hear, yeah, but I collect data. And my question is most of the time, really, or are you just having some log files somewhere that no one really analyzes? Like, are you just like logging a huge amount of stuff into some file, or do you have an actual plan? Like planning how to analyze a system is, in my opinion, even more important than the actual functionality. And that immediately leads to the question, what kind of data do you need to collect? I think for one, the minimum data for each system needs to be system health. But that just tells you, is your system working, right? So what you need to think about for each system that you're planning, or for each feature, how do I measure customer success? How do I measure customer experience? It is super hard to measure, and it's individual to each company or team or service. Like, for example, if we imagine a system, this account activity system, let's assume we envision a feature. This should send out an email on login to new devices. So some suspicious account activity. Then we send out an email. How can we measure the success of this? It is super hard because you are triggering an event, and you somehow in other systems there might be an action, meaning a user does not recognize this login, so they are opening the password reset flow and reset their password. So one example, like this is one example how you could measure customer success. For example, how long is the time right now between an account is like there happens a login to the account until the user resets a password. Like there's a user-initiated password reset via your flow, and it is not some fraud prevention system or anything else that could lead to a password reset. And in that moment, what you will end up is you can measure this lead time, and that's a customer experience metric, for example. So another big part in this plays like data science. I think the last 5 years in my jobs at least, data scientist became more and more important. Also in my understanding, that's probably just me growing. I don't think that the space changed that much, but my understanding around this, I think, changed a lot. So in order to start, now you have data, you probably have a goal, now you need to start, or like you have the metrics, now you need to start to formulate a hypothesis. For example, we've already said the example with the email and the lead time. We say, if we enable these features with sending emails on logins, we will decrease that lead time. And then you are set. You probably should name it in a way that it's measurable. For example, right now it's 48 hours or whatever time you are you're measuring, and in the future we plan to do this below 24 hours, meaning a 2x improvement. And then you can start developing this and you can start measuring. So really the most important part here is measure, measure, measure. And there can't be enough hypotheses around a system. So I think the more you have, the more you want to adjust, the better it is. And also, of course, if you see hypotheses fail, or like you fail to verify them, reflect on why and what can you do the next time better. So now I want to outline two different approaches that we took in our day-to-day life. One is a really self-contained system, which I already mentioned, which is this account activity system. That's a system, as we own the logins domain, it is only called by our system. Like we can identify, okay, what devices have we seen so far? What devices do we already know? What devices are new? So we can define all of this within our systems. There's no one affected around us, except maybe the password reset people, as they will maybe get an increased load by this. So we had no clear definition of what it should look like. We basically even started here with a name where we said, okay, this could be account activity where we store activity on the device. And then we started with a vision where this could go. And we envisioned a system that will send out emails on suspicious activity. We also envisioned this data to be probably available, maybe someone to the user. And we formulated hypotheses, as I've already mentioned. So what happened was we started then afterwards with formulating high-level tasks. Like, okay, the system should have a database, the system should be integrated into our emailing service, like tasks on this level, not really low-level tasks. And then we just started executing. Like my girlfriend always says, the best way of doing something is to simply start doing it. And that's exactly what we did here. Within 3 hours, we had a blank service in production without any logic that had 300 requests per second. It was not doing anything, but we've already saw, okay, how many of these requests is this system expecting? So we were already gathering data at that point in time. Then we started to formulate a hypothesis again and say, okay, how many of these do we already know? And we formulated a hypothesis, and we've slowly added logic here that we needed. For example, we started probably with, like usually we start to test features on employees, and then this was, for example, one of them. And then in the end, we just measured and adjusted. And adjusted here doesn't just mean adjusted the code, but adjusted the vision, adjusted the high-level tasks that we set. And then as we were 3-4 weeks in, we've decided, okay, the system now looks solid to be rolled out to employees. What are the features that we definitely need to have in place before we roll this out to employees? What are features that we need before we roll this out to our first market? And what are features that we need before we roll this out globally? The system itself is still ongoing development today, but it already, as mentioned, drifted away from the initial vision. The second approach is a system with external requirements. So the only knowledge that we had was a rough deadline when we need to have it, when we need to support this feature, and that it will be based on OpenID Connect, which is a protocol in the identity space. It is basically to exchange identities in between two internet services. For example, Google has an OpenID Connect endpoint, so you can implement here as an OpenID Connect client, and then you will know who your caller is, and therefore create an account for that person and let that account use your platform. The requirements were really fluffy because we only basically knew, okay, it's going to be OpenID Connect. It's going to be based on OpenID Connect, but it's also not really following all the standards, and there was still a lot of development going on the other side, and we knew it's a new login mechanism to Spotify. So what we did is we asked ourselves, okay, where do we see this? What teams are involved? How do they see this? And then we started with an aligned vision, meaning it was probably, I don't really remember concrete numbers, but it's probably around 10, 20 teams within Spotify, so a lot of people. So we brought them all together and said, where do we envision this system in the future, or this feature in the future? Then we started with clean APIs to our systems, which people, and already deployed them so that people can start developing from the other side. And we've measured and adjusted again, as always. One thing that I missed the whole talk now is sometimes you have a vision, but you don't know where to actually start. And this is where discovery work comes in. Usually we try to spend 1 or 2 engineers doing discovery work, meaning checking even which teams are involved, what are their requirements, what are their limitations, and then formulate these requirements in an internal request for comments, meaning an RFC document. And then everybody can share their opinion and their thoughts on a specific implementation. But again, here, if you already have a vision, then you will naturally reduce the comments on an RFC, because most of the teams are already aligned in, okay, this is where we roughly want to go. This is where this team roughly wants to go. And that's why that's why this system probably looks the way it does. So we've worked on this, we've measured, we've adjusted the vision, we've adjusted the discovery work. We probably have done some more discovery work during the project as it continued to go, and then we've finally released it. And the success story here is that today we can add a new login mechanism to Spotify within a single day. This is just on the backend side, of course, but I think given that you have so many teams involved doing such a big change in one day, that was for me something where I was quite proud of my team.